Here's another problem in moment of a force, and also simplifying systems and equivalent system of moments and forces. 250 millimeter diameter pulleys are mounted on line shaft AD. The belts at B and C lie in vertical planes parallel to the YZ plane. Replace the belt forces shown with an equivalent force couple system at A. So that means get rid of everything that you see here. Okay, shaft A, D. Get rid of everything that you see here. Put a force there. I'm just drawing a random force. I don't know. And equivalent moment. Again, I'm just putting random direction. These are 3D directions. I don't know which way they're going. We have to do a calculation. But this is what it says. Get rid of all of these forces that are happening. Move everything to point A, which as a result, you're going to have a equivalent force and an equivalent moment because you're messing with forces and moving them around. Two important questions that we have and apply to every problem. Your equivalent force is summation of all forces. Your equivalent moment is summation of all existing couples moment and summation of all R cross F's. This first one is existing couples moment, which in this problem I don't see any existing moment anywhere. So in this problem this is 0 already. And then you got to move forces. Every time you move forces, because you are moving forces around. Or moving everything to point A. So this position vector is from point A to line of action of each force. All right, let's get to work. So we need to transform all of our forces into Cartesian forces, IJK, which we have everything we need. And then we have to find R from point A to line of action of each force. And then we can find both of these. So let's just start with this equation. Okay. F, well, let me kind of name them already, so then we know what we're dealing with. So 4 forces. I don't see anything else anywhere. Let's just start with F1. The goal is to transfer that into I, J, K component. None of the forces have any I components. It says that everything, everything is on YZ plane. So there's no I with any of them. So it's all J and K. All right, this force has a vertical component. This is Z, this is Y, this is 145 newtons. This is the angle 20. So it's going to have a 145 sine 20 in Z direction, and it's going to have 145 cosine 20 in negative Y direction. So minus 145 cosine 20 J, 145 sine 20 K. Units are newtons. F2 is much easier. It's just a straight down. So it's 215 negative J. Units are newtons. F3 Z, Y. F3 is like this. 155. Both of them, F3 and F4, have an angle of 10 degrees. So we are looking at 155 cosine 10. And we are looking at 155 sine 10. So I'm going to write them down here, a little bit more room. F3 is going to be minus 155 sine 10, and that will be J. 155 cosine 10, that will be K. Units are newtons. F4 is the same, it's just the magnitude is different. Minus 240 sine 10, and that is J. Minus 240 cosine 10, and that is K. The units are Newton. Step 1 is done. All of the forces now is in Cartesian form. All you have to do is just add them together. So let me write them here. So you're going to have, I keep them, I don't do the math. I usually keep them like this until last minute. So then everybody can kind of follow. You know which one is what. J minus 155 sine 10. You can fast forward if you have already done the math. You don't need to watch me do it. You can skip ahead to the moment part. But I'm almost done. Sorry, it's a little bit short on space. So what you do is you add all the J's together. J, 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 J. So is going to be minus 41985 J. And then you do all the K's together. There's one here, there's one here, there's one here. And that should result in 339.4 K. The units are Newton. If you want to write it as a 3 sig figures, we can say minus 420 J minus 339 K. Units are Newton. Nice numbers. All right, part 1 is done. Let me just go back quickly here. This equation is done. Force part is done. Now we got the couple system. We got to go back to this equation right here. So for each force, we have to find a position vector from point A to line of action of each force. So we'll start with 1. Again, F1, F2, F3, and F4. And this could be a little bit tricky just because it's belt and stuff like that. But nothing that we can get through. So the line of action of F1 is right here. So I got to go from point A to this line of action. You can go anywhere. I should add here to anywhere. Line of action. You can go anywhere. You can go here. That's R1. You can go here. That's R1. Those are all acceptable. But I usually go somewhere that I can calculate a position vector for. So I'm going to go here for x-axis and then this point right here. Whatever you want to call that point, B prime. That's all right. This is something I can calculate and I can figure out because the x component of it is 225 and the k component of it I can figure it out quickly. Let me draw that belt right there. It has an angle, so it goes like this. This is my force 1. This is center of the pulley. This is my force 2. So if I can find this length here, this length right here, that's the k component of the position vector. I can find it. The diameter is given 150 millimeters. I usually like to write it in meters. So 0.75 meters. The angle is also given 20 degrees. So this length right here is 0.75 divided by cosine of 20. So in other words, my R1 is going to be 225I plus 0.75 cosine 20, and that will be K. The units on it is meters. This is point B prime that I talked about. If we go to point from A to point B double prime, that will be my R2, which is right here. So it will be 225I minus 0.75K, and that is meters. Okay, my R1 and R2 done. Kind of same thing for R3 and R4. We go kind of pick that point on the line of action right up here. Wish I had more colors. We go right there for R3, which is 225 plus 225, so it's 450I, and the rest is in Y direction. For the first one, here, let me draw the circle right here. So it's like this, because they have an angle of 10 degrees. This is the center. This is what I'm trying to find. I didn't draw a good force here, because the pulley is rotated a little bit. There, much better. So this is the 155 Newton. This is the 240 Newton. The line of action of the force is right there. This is where I'd like to go. So this is the length I'm trying to find, to see how much, and this is in y-axis. So again, this angle is 10. This diameter is 0.75, so this length would be 0.75 divided by cosine of 10. Plus 0.75 cosine of 10, and that will be positive J. Similarly, for the bottom one, line of action is here. I like to just go straight down. Same length. The only difference is in negative Y direction. If it's a little bit confusing, I totally get it. Please pause. Please figure this triangle right here. This is 10. 0.75. 0.75 divided by cosine of 10. This length here is going to be 0.75 divided by sine of 10. Do the trick, do the math, and you will realize it. So please pause here if you want a few minutes to figure this part out. But we're going to move on to making all the R cross F's. Remember, this is what we are trying to do, summation of all R cross F's. So I'm going to set up my determinants. I, J, K plus, I have 4 forces. ijk, ijk. I have a full lecture on this, and moment of a force and cross product. So if you would like to watch those, so this won't be for F1 or R1 F1, R2 F2, R3 F3, R4 F4. So please, you can go back and all the R's are here, all the F's are here. So all I'm doing is populating the matrix and writing these in the matrix. So I'm going to go a little bit faster, and you're more than welcome to fast forward. I still keep it as fractions I had again, so it's easier to keep track of. Otherwise, you can absolutely do the math on these and just write the final number. I guess I did final number on one of them. 225.075 meters 0.2150. So again, I'm just writing the component of each force and each position vector into the matrix. If you're a little bit confused about it with that, what I'm doing, please go back, watch other lectures on cross product and moment of a vector. I should also have a video of how to do the calculation of determinants of this matrix. Sorry, this is not the best, running out of space a little bit. Cosine 10 and 0, 240 sine 10, and then 240 cosine 10 meters and newtons. All right, again, pause here, do the math. Once you do the math, your equivalent moment is going to be something like this. It is possible I make mistakes here and there in the math, so if you don't get exact these number, that's fine, as long as you understand how to get to this determinant and all your determinant looks okay. Don't worry about the math as much. Blame it on me, and it's possible that I make some mistakes along the way, and this answer is not the correct. So I'm just writing the FR just for your reference if somebody was wondering about that as well. Thank you very much.